Let's continue our discussion and look at unguided or wireless communication media. Now we typically find three frequency ranges, namely radio, microwave and infrared. Now if we look at radio wave frequency, these operate within 3 kHz ranging up to 300 MHz. So typically what we find is in many cities and towns we've got a lot of base stations. Now these are mounted on buildings or either on lamp posts and other dedicated posts, and they would typically send information from one station to another. Our next category, microwave communication, operates within the frequency of 300 MHz going up to 300 GHz. So these are high frequency radio signals that are sent through atmosphere and space, and in many cases operate with various satellites. Now typically we get two subcategories here, namely terrestrial and satellite. So if we think in terms of terrestrial microwave communication, these are communication types that require line of sight. So you would have stations that need to be able to see each other, and it's roughly 50 kilometers apart. So these, again, if you drive on country roads, you would typically find these big towers with the radio wave stations on top of them. So what will happen is you will have a sender, you will have a receiver, it's going to send a signal, another station will receive that signal, amplify it. Remember we've spoken about attenuation before. So it's going to take a signal that might have become a little weaker, it's going to amplify it, and then it's going to retransmit that signal to the next station. The disadvantage of terrestrial microwave communication is we need to consider obstacles and the curvature of the Earth, and that's why we need to limit ourselves in most cases to the 50 kilometers. If we look at satellite communication, we find that there's three subcategories. Now satellite communication, if you look at the picture below, typically it's where you've got ground stations, and these stations communicate with a satellite in space. Quick examples include things like your satellite television, as well as your broadcasting stations that we typically find for our TV stations. So there are three types. We get what is known as geostationary satellites. These are approximately 35,000 meters above the equator, and they will appear stationary. So again, if you think about your DSTV and your satellite TV channels, your dish on the outside remains in one position and it has communication with that satellite the whole time. So stationary. Then we have low Earth orbit or LEO satellites. These are roughly 1,600 kilometers above the Earth, and what typically happens is these move at their own speed, so they don't really remain fixed, but you do require that there's a grid of some sort where one of these satellites can communicate with any other satellite. Otherwise they will have no communication and no link. The last category when it comes to satellite microwave communication is VSAT, or very small aperture terminals. Now these are typically your ground stations that's smaller than 3 meters in diameter, and this is again typically what we see with our satellite TV. Now let's go and look at the last category, infrared. Now infrared uses frequency light waves that is transmitted between nodes. The signals will operate within the range of 300 gigahertz going up to 400 terahertz. Now I'm sure everybody's familiar with infrared communication. We find it in most of our remotes. So in your remote, when you press a button, when you change a channel, a light wave is transmitted and that sends a signal to another device, and that operation is executed. We see some examples in certain cell phones. At the stage we had that, where you could have controlled, let's say, your TV with a cell phone, or you could have sent information from one cell phone to another cell phone by using infrared. Now let's look at each one and see what their advantages and disadvantages are. So if we look at the first one, radio wave frequencies, these are typically where we find our mobile users. We find that it's becoming cheaper and cheaper because there are more competition in the market, and where companies are actually starting to share information being sent from one provider to another. The disadvantages: these signals are highly susceptible to interception, so anybody can intercept and try to decode the communications and the messages. If we look at microwave, terrestrial and satellite communication, these are typically used where we don't want to lay physical cables. Let's say it's a rough environment, there's a tendency of people stealing cables, all those kind of issues, then we would opt for these. We're also going to have high speed transmission rates, so it's going to be better than cables. The disadvantage that we do face is they need to have line of sight, so there shouldn't be any obstructions. Otherwise, communication cannot take place between the sender and the receiver. They are also very highly susceptible to interception, so again, depending on the use, it might not be suitable for that particular case. The last wireless communication that we talked about, infrared. Now, the nice thing about infrared is you can actually go and move, remove and install new devices without wires. The only thing that you do need is that they have line of sight again. So that becomes a disadvantage. So unobstructed view, line of sight, and very effective for short range communication. But for your longer ranges, you will consider microwave and radio frequencies. Now, just for interest's sake, if we look at wireless communications, we do find that it's highly regulated in most countries. In South Africa, we're talking about ICASA, where whenever you want a radio station or television stations and these things, they have strict licensing requirements. Now, this is just a range of the frequencies that we have. So we set for radio frequency, we started in about 3 megahertz going up to 30 kilohertz, or sorry, 30 gigahertz, and then our other signals start to come in going up to about 400 terahertz. Okay, so these are the major ones that we're actually working in. There are some other ranges. For example, if you go to a hospital and they take X-rays, you would find that these are very damaging signals and they try to limit people. We do find that in our daily lives there's actually hundreds of waves passing right through us, which allows us to pick up TV signals and radio signals and those kind of things. Okay, so just perhaps a little background. Now, whenever we talk about wireless communication and the types of signals that we can find, it's also important to know what technologies are available. So we're going to look at stuff such as NFC, Bluetooth, UWB, as well as Wi-Fi. So let's look at each one in more detail. If we look at NFC, which stands for Near Field Communication, this is typically where you've got a device that would listen to signals, and as soon as an object or tag comes into its proximity, it's going to pick up that signal and it's going to have a unique frequency for that. So we would typically find this in things like student cards, access control cards, and then your personnel cards at industry. So it's a very short range wireless medium, and it's mainly, the idea was that it was for cell phones and credit cards. So on certain cell phones you might find that there's an option to enable NFC, and then if you bring an NFC enabled to a RFID card close to that cell phone, it will actually pick up that signal. We do find it with the newer credit cards, where we've got cards such as Tap and Go, where you can take your credit card, you tap it on a device, and the device picks up the necessary information. These types of environments or systems require you to be very close to that receiver that picks up the signal. So we're talking about millimeters or centimeters at most. So we find it at point of sale systems. In factories we find it where as soon as lorries drive into a warehouse with goods, it can actually go and pick up these tags with the frequencies embedded on them, and it then goes and it registers them on the different systems. We find some other uses overseas, mainly where you can get information on posters. So you take your phone, you tap your phone on a poster and it receives information. Wireless communications between offices and your devices, paying for bus tickets, paying for various goods, sharing business cards. If you want to be hip nowadays, you can have a business cards with embedded chips, so people can just tap on your business card and they've got your information at hand. Some other uses that we find overseas where they use it in advertisements, where you can take your device, you tap on whatever you want information from, and it's going to give it to you. In shops where you want to get more information about specific products, kilojoules, all those kind of things. If you're into health, then again you can just go and tap your phone and immediately the necessary information will be displayed on screen. Now let's look at the next one, which is also a very popular one, Bluetooth. Now Bluetooth again is a wireless communication specification and is mainly used in our mobile phones, computers and printers. The disadvantage of this one, however, is we're limited to about 3 to 10 meters. So if you think back to NFC was millimeters and 1 or 2 centimeters in most cases. Now we can go up to from 3 to 10 meters. We can send a little more information, 2 megabits per second. And it's mainly used to synchronize information between various devices. So we do find this on cell phones where, let's say for argument's sake, you want to send information from one cell phone to another cell phone. Then you can use a Bluetooth enabled device where you've got wireless keyboards and you need to have communication with, let's say, your computers or your earphone. Let's move on to some other uses of Bluetooth. Now we've seen that it has actually evolved where we find smart devices. Now these are typically your tracking devices, smart watches, health devices tracking your blood pressure, your daily activities, step counts, those kind of things. Overseas there are uses where you find it in your computers, your motorbikes, your footwear, your sneakers, in your cars, hands-free devices. So there's a bunch of uses of this. So if you're interested in this, go to Google, search for Bluetooth enabled devices, and there's actually a bunch of categories where you would find that they are being used. Now let's look at the next one. The next technology is known as UWB, or ultra wideband. Now with ultra wideband we're going to send very short electromagnetic pulses. Now it's extremely short, it's in the range of 50 to 1000 picoseconds, and it sends a broad range of frequencies of several gigahertz over those different types of media. These types of devices use very little power. They transmit large amounts of data over ranges from about 10 meters up to 50 meters. And the advantages of these are they have a very high throughput rate. It's undetected, there's no chance of interception, and there's actually no interference from other devices because it's these very short electromagnetic pulses. Where do we find them? Typically nowadays in your mobile storage devices, media players, printers, scanners, web cameras, speakers, etc. Some other uses that we do find on the internet, you can have your whole office system all your devices link through UWB. None of them would interfere with any other devices. We find these especially overseas in old age homes or in hospitals where they've got various sensors connected to individuals, where those sensors can continuously send information to the doctors and nurses. For example, if somebody is not breathing correctly, or if they've got heart fluctuations, those kind of things, without them realizing that something is wrong, the system can immediately inform the necessary people. The last technology that we're going to look at, Wi-Fi. Now Wi-Fi, I think everybody is familiar with that as well, and we typically find it nowadays in our routers. So you've got internet up to a certain point, up to a router, and then you enable all your devices to communicate with that device through the Wi-Fi technology. So it's a medium range wireless communication technology owned by the Wi-Fi Alliance, and it enables our devices to send radio signals between each other. So there's an antenna that sends signals and receives signals, which allows us to actually go and set up a small network of types. We can actually go and create wireless access points, and then many people might have heard about the term hotspots. So hotspots is where you've got a region that's covered by this transmission of this particular device, and where other devices can actually link up to that device in order to have communication. Now, what are the ranges? Inside buildings, we typically find that it works in the range of about 30 meters, and then if you use it outside where there's no obstructions, it can actually go up to 100 meters. Now, we have seen that Wi-Fi has changed the way in which we connect to networks. So with the older networks, we would have had a lot of wired or guided media between our devices. Now we've got wireless, we've got a router, you've got a wireless access point which is connected to a router which is indirectly connected to the internet, and then this wireless access point sends signals which your devices can pick up, which enables you to communicate to this wireless network, the Wi-Fi network. We do find it in devices such as our TVs and our computer screens and printers and various other devices. The last things that we need to refer to perhaps is known as our wireless communication mediums, our broadband media. Now this is where we're starting to talk about 1G going up to 4G, 5G is still coming, as well as LTE. Now if we look at it, it typically comes down to the type of technology and the amount of data that could be sent at that particular point in time. So our cell phones started off with 1G. This was when they used analog communication, sound waves. It only allowed us to send a certain amount of information at a time, very slow, not very efficient, and a lot of limited uses. That was replaced by 2G. Now 2G was full digital networks, which allowed for encrypted conversations. It expanded our mobile usage. It introduced us to aspects such as SMS or texting, and then that again was replaced by 3G. 3G supported wireless voice and broadband speed communication, so yet again the speed increased. And typically nowadays we find that we have 4G, which is more advanced. It allows us to send multimedia, to stream videos, to have universal access to various devices and access points, and then portability across various devices. Closely linked to 4G, we might find a concept known as LTE, or long-term evolution. Now, the difference between 4G and LTE, and there's a lot of controversy about this, is it's just a different way of communicating on the system. So we're not going to go into detail here, but with It changed from using circuit switching going into packet switching. So with 4G you would have typically found that they use circuit switching, which is a specific way of sending information, and now that information is changed a bit and it's sent independently, and that's where LTE comes in place. So that required that a lot of the voice networks had to be re-engineered, but ultimately it resulted in quicker communication. The next version that we expect is 5G. Now 5G isn't available at this stage. It's estimated to be introduced in 2020, and this one promises very high transmission rates, low power consumption, high connectivity reliability, and then increased coverage and lower costs. The last standard that we can look at, which you might also find from time to time, is known as WiMAX, which stands for the Worldwide Interoperability for Wireless or for Microwave Access. Now, WiMAX is a specific standard that was created. It works similar to Wi-Fi, but it covers greater distances and it sends faster. It has faster transmissions. So if you think about the limitations of Wi-Fi, inside it was 30 meters, outside 100 meters, and then with WiMAX it would cover up to 50 kilometers. So similar concept than Wi-Fi, but larger ranges. Just to give you an idea of the evolution of our mobile phone communications, from 1G going right through to 5G. So for our very first phones, starting from roughly the 1980s, we had 1G, lasted for about 10 years. Then we saw the introduction of 2G, codenames GSM, GPRS, H, replaced by 3G. Then we see 3G roughly from about 2005, and that's currently what some users might have. We're starting to see 4G, and then a combination of LTE and LTE Advanced, and then the future estimate is that we're going to have 5G. In our next section, we're going to start to look at network types and network topologies.